today. 4-3 part 1, and then we'll finish it tomorrow. On Thursday, we'll do 4-4. Friday will be a Math Excel work day for you, so you'll have time to get caught up on homework. I think Math Excels are both due on Sunday night, if I remember correctly. Let me double check that. One was Friday, one was Sunday. Monday. Yes, Friday, Monday. All right, so 4-3, this guy's going to be due on Friday, but you'll have Friday in class to work if you want. And then 4-4 that we're going to do on Thursday will be due on Monday. All right, rules for logarithms. Let's get started. Okay, so there are 3 rules that we are going to use for a good chunk of our problems in this section. The product rule, the quotient rule, and the power rule. You need to get all 3 of these in your notes, and then on the right side, leave a little space because I'm going to include an example of what it looks like with some numbers filled in so you can see how these properties work. We use these properties to either take a single log and expand it, so write it as multiple logs, or take multiple logs and condense them, write them as a single log. So we could use the property potentially in 2 different ways. Make the left side look like the right, or the right side look like the left. These rules come from kind of a scaled back version of our exponential properties. When we did exponents before, we talked about if you have the same base and they're multiplied, you add the exponents together. You're going to see multiplication and addition again. They're buddies here with our logarithmic properties. When we did exponents and we were dividing with the same base, we subtracted the exponents. So again, you're going to see division and subtraction buddies again, because remember, logs are just really exponents in disguise, or the inverse of our exponential function. So you're going to see a lot of overlapping rules and properties between the 2. All right. Examples of each of these I'll include on the far side here for you, and then you can have one of each at least written down for us to practice with. Starting with the product rule says if I have log base A of mn, I can write that as log base A of m plus log base A of n. Notice everything's a base A here. It doesn't matter what the base is, but they all have to be the same base. It's just like with exponents. If they don't have the same base, you can't combine them together. Same rule with logs. They have to have the same base to be able to combine them together. And most of the time when we use this property, we'll use it in this order. We'll take 2 logs that are the same base. I'm going to say log base 4 of 5 and log base 4 of 3. And we want to condense them. We want to combine them. We want to put them together. This property says the log base remains the same, stays a log base 4, and then we just multiply the numbers that are inside the log together. So 5 times 3 gives me 15. Okay, and then you can do it the other way if you needed to. You can take that 15, break it up into 5 and 3, and separate it into 2 separate logs that have that same base if you needed to. Quotient rule, again, they need to be the same base. So let's say I have log base 4 of, 9 minus log base 4 of 2. All right, like that. I can combine those together by keeping my log base the same, still a log base 4, and then I divide my numbers. And subtraction order is important. So whatever's in the first log needs to be your numerator, 9. Whatever in the second log needs to be your denominator, 2, and then you could write that as like 4.5 if you wanted to. The power rule can be used one of 2 ways. Either we have a log with a number to a power, and we can bring that number down in front of the log, or vice versa. We can take a number in front of the log that's multiplied and move it up into the exponent. This one we really do use both ways, probably equally. So if I have like 2 log base 4 of 3, I could take that 2 and make it a power of the 3. So log base 4 of 3 squared, and then you could even simplify that one a little bit more and say it's log base 4 of 9. Okay, or if you have that exponent 2, you can move it down in front. Moving that exponent down out of the log is actually going to help us solve for exponents a little bit later on. We're going to focus on that a little bit in this lesson, but then a lot in section 4.4. Okay, so those are our 3 log rules. If you're adding, you multiply to combine them together. If you see subtraction, you divide to combine them together. Again, just like our exponent rules, multiplication and addition are friends, subtraction and division are friends. And then if you have an exponent, you can either move it down in front, or a number down in front, you can move it to the exponent. Okay, everybody have what they need here? All right, so let's practice. These first 4 problems we are going to write in condensed form. When you see that you want to condense logs, it means you want to take multiple logs and write them as few as logs as possible, potentially get it down to a single log if you can. Again, to be able to condense them, combine them together, they need to be the same log base, which all of these are. If not, you just would say, I can't do it, can't combine it any further. If you don't see a log base there, like those first ones on the top left, what number could you put in that little subnotation if you wanted to? It's a 10, it's a common log. You don't have to write that though. All right, so in my first one, I have 2 logs. They're both log base 10, they're both common logs, they're subtracted. How do I condense them together? You change it to a division problem. So it becomes log, and then I'll put in parentheses so it doesn't look like a subnotation. 3x is my numerator, 4y is my denominator. 3x over 4y doesn't reduce any further. Final answer. Okay. The next one I have 2 times log base 2 of 5 plus log base 2 of 9 minus log base 2 of 75. All right, so I have a little bit of everything in this problem. I have a number down in front, I have addition, I have subtraction. So this is kind of like what you do with order of operations. Order of operations, you do parentheses first, which we don't have any. The next thing you deal with are exponents, which I don't have any exponents right now, but I can make something an exponent. That 2 in front, I can move and make it a power on the 5. So I'm going to do that. Log base 2 of 5 squared plus log base 2 of 9 minus log base 2 of 75. And 5 squared, you can simplify a little bit further and turn it into 25. So I have log base 2 of 25 plus log base 2 of 9 minus log base 2 of 75. And everything still stays log base 2. That's never going to change. All right, now I have addition and subtraction. If you want, you can just do this from left to right. I will tell you though, if something is added, it's going to end up being in the numerator. If something is subtracted, it's going to end up being in the denominator, because addition means multiplication and subtraction means division. So that can help you do it all at once if you want to. If I did this all at once, I would say log base 2, the 25 is multiplied by the 9, and that would be in my numerator. And the 75 would be divided in my denominator. And then you can simplify that a little bit. 25 times 9 gives me 225 divided by 75. I think that just gives you 3. You can double check me on that if I simplify inside that parentheses. And that would be your final answer. Okay. Questions there? All right, with your groups, I want you guys to see if you can try the 2 at the bottom. And I'm going to give you a hint. A 1/2 power is the same as what? Square root. 1/2 power is the same as a square root. All right, give you a minute. All right, let's talk about them. So I showed my steps here. For the one on the left, first thing I did was I took my powers and moved them up. So second power and a 1/2 power. The next thing I did is I had addition between my natural logs. So I changed that to multiplication, and that gets rid of one of the logs. You should only have one log left after that step. And then the last step is kind of a little hint I gave you guys. I have a 1/2 power, so anything that's taken to that 1/2 power is technically under a square root, is what that means. So we're going to write our final answers if you see a 1/2 power with a square root, or a 1/3 power as a cube root. And it's just over what that parentheses was. These are still multiplied together. Sometimes you might even see like an extra little parentheses in front of the x squared and after the radical to just emphasize that it's all inside that natural log there. Okay. The next one, I kind of work from the inside out. So I combined these logs together first. It's addition between them. So I made it multiplication. And you can multiply these together. X plus 1, x minus 1. When you FOIL it out, it gives you x squared minus 1. That's our conjugates. Then I moved my 1/2 power up. And then I just wrote it as a square root for that last step. Questions on condensing? Think of it like an order of operations. Parentheses, powers, addition changes to multiplication, subtraction changes to division. No? Okay, the next set of problems, we're going to do the opposite. We're going to have a single log. It's going to kind of look like one of these answers, and we're going to expand it. We're going to write it as multiple logs. So it's going to be in reverse now. If we see division, we're going to separate it into two different logs that are subtracted. If we see multiplication, we're going to separate it into two logs that are added. And if we have any powers, we're going to move them down in front. Okay? So let's start with this first one. I've got natural log of 2x minus 1 over x plus 4. Instructions are to expand, which means, again, write in as many logs as possible. The log base will not change. So if this guy starts as a natural log, everything I write in the rest of this problem will be a natural log. So I want to check for the following things. Number 1, do I have any exponents that I can bring down? No. Number 2, do I have any addition or subtraction between two different, or sorry, not addition or subtraction, that's not what I want to say. Multiplication within my log. I don't have any multiplication. I have that 2 times x, but the minus 1 is preventing me from separating it anymore. I also am looking for, do I have any division? I do have division. We have a fraction. Fraction represents division. Division changes to what operation? Subtraction. So my numerator will be with my first log. My denominator will be with my second log. They are both natural logs when I write them. So it's going to be natural log of my numerator, 2x minus 1, minus, because it's division, natural log of my denominator, x plus 4. Now when we're expanding, again, we're looking for the following things. Powers that we can bring down. We don't have any more. Any more division. We don't have any more. I do have multiplication with the 2 and the x. But that minus 1 is preventing me from going any further with that term. If I just had natural log 2x, I could separate it a little bit more, but the minus 1 stops me. Okay? Let's look at the next one. I have natural log and then a square root of x to the third, y squared, z to the fifth. It is helpful to kind of work backwards, like the problems that we did before. If you have a square root, what power is it? The same as. So 1/2. So I'm going to write it like this. X to the third, y squared, z to the fifth, to the 1/2 power. Okay. I can't touch anything inside that parentheses until that 1/2 power is gone. Where can I put it? According to the power property, I can move it down in front of my natural log. So I have 1/2 natural log, x to the third, y squared, z to the fifth. Okay, I don't have any division in this problem, but I do have multiplication. The x to the third, the y squared, the z to the fifth, those are all multiplied together. Multiplication changes to what when I expand it? Addition. So it's going to be 1/2, and that 1/2 is going to be out front of everything, so I'm just going to put a little bracket there. I'm going to have natural log x to the third plus natural log y squared plus natural log z to the fifth. So all of those multiplications, all of those products become sums. They become addition. All right, so now I want to kind of run through what I can do. Move my power down, change my multiplication to addition. I don't have any division, but I still have powers, right? And that third power, the second power, and the fifth power, I can now move down in front of their respective logs because I separated them from each other. So I can make it 1/2. 3 natural log x plus 2 natural log y plus 5 natural log z. I have no more multiplication, no more division, no more powers, so I know I'm expanded completely. An optional step here is you could distribute the 1/2 through if you wanted to, but that doesn't make it any more or less expanded, so I'm just going to leave it there. Okay? All right, see if you can try the bottom two with your groups. Expand using your rules. All right, at the bottom is the final answer. So I wrote my square root of the 1/2 power. I moved the 1/2 down, and then anything that's in the numerator, remember I said that's going to end up being addition because it's all multiplied together. Anything that's in the denominator has been divided, so that's going to end up being subtraction. So the 4, the x, the y, those were all multiplied together. So when I expand, those become added. The z in the denominator is divided, so there's a minus in front of it when I expand it. Again, you can always distribute that 1/2 through if you want to. For this guy, the first thing I did was separate it. It's multiplied in the numerator, that becomes addition. It's divided, that becomes subtraction. Make sure everything is a log base 2 in every term that you have written there. Then I have powers. The 2 comes down in front, the 3 comes down in front, the 4 comes down in front. I do have multiplication again with that 2 and x there, but because that +1 is part of that term, I can't separate it any further. The whole thing inside the log needs to be a product or quotient, multiplication or division, to be able to expand any further than that. So I've got that sum there. I can't go any further with it. What questions do you have there? Expanding. No questions on those? Okay, I've just got one more slide for you, and actually we're going to use expanding to help us on this next slide. That'll be it for today. All right, so you're going to see some problems like this on Math Excel. They're going to give you some information about logs. There might be x's and y's, there might be numbers, it just depends what's in the problem. In this case, we're given that log base 5 of z is 3, and we're given log base 5 of y is 2. You are not to solve for x and y. Sometimes you'll be able to, sometimes you won't. You don't want to rely on that strategy. The goal here is we're going to take an expression and we're going to expand it as much as possible. Once it's expanded, we're going to be able to find log base 5 of z and just replace it with 3 wherever I see that at. Or if I see log base 5 of y, replace it with a 2, and that's going to give us an exact answer. If you try to solve for the variables, your answer will be rounded in most cases, and it will be wrong in most cases. So instead, when you see a problem like this, the kind of hidden instructions are expand it completely, and then we're going to substitute in the numbers that were given to start. So those numbers at the top, you're going to use very last in the problem. So my first problem says I have log base 5 of y times z. So if I were going to expand that, because it's multiplication, it would expand using what operation? It would change to addition. So it would be log base 5 of y plus log base 5 of z. Now I have a log base 5 of y. I'm actually given what that's equal to at the top. I have a log base 5 of z. I'm given what that's equal to at the top, so I substitute them in. Log base 5 of y is equal to 2. Log base 5 of z is equal to 3. The log evaluates to 5. Okay. I'm going to do the one right below it, and I'm going to let you guys try these last ones then. I have log base 5 of y squared z to the third. So my first step is going to be expand that completely before I try to substitute anything in. What can I do first to expand that? What would be your first step? I have powers and I have multiplication, right? Can I move those powers down? Not yet. Okay, because the y and the z are multiplied together still. We need to separate those from each other, and then the powers can move down in front of their respective logs. So how do I separate the y from the z? It's multiplication, so it changes to addition. Log base 5 of y squared plus log base 5 of z to the third. Now, if I had a power outside of this parentheses, I could absolutely bring it down. But if power is inside of parentheses, you need to separate them from each other first because they're going to have their own logs when we bring them down. Second, I'm not expanded completely because I have those powers. I must bring them down. A common mistake here is people will substitute too early. There is no parentheses here, like this. If I had a parentheses, I could substitute log base 5 of y in. But we don't have that. We have log base 5 of y squared. We don't know what y squared is equal to. So what we need to do is bring those powers down. 2 log base 5y plus 3 log base 5z. Double check that I'm expanded completely. There's no more multiplication. There's no more division. There's no more powers. Substitute in what you know. Log base 5 of y is equal to 2. So I have 2 times 2. Log base 5 of z is equal to 3. So I have 3 times 3. 2 times 2 plus 3 times 3. My final answer is 13 here. Okay. The last 4 are yours to try. I'm going to have 4 groups, put them up on the board in a few minutes here. Go ahead. Expand completely, substitute in. You should end up with a single number at the end. First one, log base 5 of y minus log base 5 of z. Substitutes into 2 minus 3, gives you -1 is correct. The next one, log base 5 of 125 plus 7 log base 5 of y. When you substitute, it's 7 times 2, which is where you're going to get 14. This piece is actually just review, guys, from the last section. Log base 5 of 125 means find the exponent, right? 5 to what power gives you 125? That's going to give you the 3, and that's where the 17 is coming from. Down here, expanded completely, and these guys distributed the 1/2 through. You don't have to do that. You can leave it up front if you want, but either way, when you substitute in, you should get a 1/2. And then last but not least, you're going to have 1/30 times 3 plus 5 times 2, which is going to give you 10 and 3/30 or 10.2. Okay. All right, tomorrow we've got a couple little add-ons with these properties, and then we'll wrap up 4.3. Try to start your Math XL tonight. I'm telling you guys, circuit training is one of the easiest ones we've had in a while. If you haven't grabbed one, you might want to try that. You've got a week to work on that. Cell phone lotto, I'll do our winner here. Tests, I need back. Can you guys put your tests, both parts of it, just on the round table here for me? Let's make a pile. Grab your sticker if you want them.